We're going to work on keeping this on schedule. The next panel is, I think, an exciting one, so I was happy to be asked to come in and moderate for it. And this is looking at the future of low Earth orbit, sustaining vital research, commerce, exploration through private space stations. Now, there aren't very many private space stations now, but people are looking forward to there being more space stations. The speakers we have in the panel tomorrow morning, Robin Gatens from NASA. She's director of the International Space Station program right now. And so, of course, which is one of the biggest and most active laboratories in low Earth orbit. We'll have Jeffrey Mamber, who has a long experience working not only with commercial space stations in terms of his prior experience with Russia, but also is deeply involved in private space station development now. And then we have my friend Masami Onoda from the Washington office of JAXA, and Japan is planning its future space station as the International Space Station transitions to more work in the commercial sector. So you're going to get a NASA perspective and looking forward civil space. You're going to get an international perspective from one of our major partners, and you're going to hear a commercial perspective from someone with long experience in private space activity. I'm told that there is videos associated with each one, so I will simply pray that the technical people can bring this up, but I will look forward to them. And then what we will do is, after remarks and video, we'll shift into Q&A. Questions are would come in on Slido. I have an iPad here, so I will hopefully pick some good questions. If not, I'll make some up. And we'll proceed really starting with Robin. To introduce yourself. Yeah.
Good morning, everyone. I'm Robin Gatens. As Scott introduced me, thank you. Director for International Space Station. I'm at NASA headquarters in the Systems Operation Mission Directorate. And my role there is dealing with overall policy, strategy, and budget for the International Space Station program. And I work a lot with our stakeholders in Congress and in the administration. And one of the aspects of my job right now, it's keeping me very busy, is this LEO transition from International Space Station to commercial space stations that will follow in low Earth orbit, and figuring out all the complexities associated with that transition plan. So we are moving from an era of owning and operating a government platform together with our international partners to an era where governments are going to be purchasing services from commercially owned and operated platforms in low Earth orbit. And how do we do that transition? It's really important for us to provide continuity, and we'd like for this transition to be seamless, so that users coming to International Space Station today don't have to worry about what happens next. We have that figured out. The capabilities are going to exist. International partners, we have a way for international partners to participate as we continue in low Earth orbit together, doing things as a partnership as well. Another aspect is our space station, International Space Station National Lab, that brings in other users, not NASA, to do commercial research and development, other government agencies. So how will that work on commercial space stations? So all of these kind of complex, interwoven strategies are what we're working on today to make this transition smooth. And with that, I will have a video we can queue up. It kind of shows from the NASA perspective this vision for what's to come.
LEO, it stands for Low Earth Orbit. That's a portion of outer space about 250 miles up. And for over 20 years, it's been home to the world's most unique laboratory, the International Space Station. In this weightless environment, the space station has enabled scientific and engineering breakthroughs that just weren't possible on Earth. It's taught us more about our planet, physics and biology, and it's preparing humans to travel farther from home than ever before. And as the space station approaches its end of life, America will maintain leadership in LEO by enabling a new era of commercial spaceflight. Through the Commercial LEO Development Program, NASA is working with industry partners to develop the first generation of commercial space destinations. These will be privately owned and operated space facilities, where NASA will be just one of many customers. This new orbital economy will stimulate commerce and usher in the next generation of aerospace engineering, opening the door for scientific discoveries and private astronauts, allowing NASA to continue its critical research in LEO, supporting deep space exploration and bringing those benefits back home to Earth. Welcome to America's future in low Earth orbit.
I like the pictures of the space station that show it very messy with lots of wires and equipment. So this is not a science fiction space station. This is a real research facility and been in use for many years.
It's very busy. We have crew and cargo vehicles coming and going. Lots of research. We've really built this capability up for the past 2 decades, and now we're in our 3rd decade and just using the heck out of it, and we'll continue to do that through 2030.
Very good. Let me turn to Masami next, also one of our key partners on the space station.
Yes, we have been a partner of the International Space Station for a long time, since the beginning, and proud to be so. We contribute the Japanese module called Kibo, that means hope, and to conduct experiments, science demonstrations, technology demonstrations on it. And we also provide logistics support by HTV, and now going on to our enhanced version that will be called HTVX. Also, we have a control center in Tsukuba, and together with our launchers, and astronauts, of course, that's what we contribute to the current space station. Going on, we have last year in November, the government of Japan agreed to extend the operations of our Kibo module and the ISS participation through 2030. We're happy to do so and also be part of the transition studies to find out what we want to do after that with our commercial partners. And it's a very exciting time also. We have a dedicated team of commercial business development that's newly created in JAXA. And we have a whole group working on overall space cooperation, what we call co-creation with the commercial partners. So it's really international partnership, commercial partnership, and a new era for Japan and internationally, I believe. And can I show the video now?
That's terrific. And, how is it, I want to maybe ask how this program has excited or connected with the Japanese people, in terms of public interest in space. There's been a long interest in space, of course, in the U.S. for, a long time going back to our original history, but how has this been in Japan? How is this connecting?
Oh, yes, I'm sure it's exciting a lot of people, not just the industry, but also JAXA, to enter this new stage of commercial collaboration. You could feel the excitement in the video that they made. It's almost the best video I saw coming from JAXA. So, we have maybe now up to 100 or so new, what we can call new space, that's been going on for 10 years almost now, but and now we have like an ecosystem in Japan that's exciting all of us. In my office, I have visitors almost every day from Japan and the US industry talking about what we want to do. And also the government is trying to add a new function to JAXA to be able to fund these commercial entities. So that's just also being discussed now. A change of the system is being discussed, and we'll see that coming very shortly.
So, okay. Very good. Jeff Manber.
Thanks, Scott. I'm Jeff Manber, president of International and Space Stations for Voyager Space. Also chairman of the board of NanoRacks, a company I co-founded that's grown into one of the largest commercial users of the International Space Station. And it's great to be on the panel because it's as we're learning, as we all know, we're entering a new era now where the public-private partnerships between the private sector and the space agencies of the world, they're growing more robust. I forgot, you don't like the phrase public-private partnership. But anyway, forgive me. And so it's growing far more robust. And what's happening is more and more space is becoming a normal place to do business, where the private sector takes on more and more risk, puts in capital, and for today, a lot of the existing infrastructure has been paid for by the space agencies of the world, but especially in low Earth orbit, that's going to change as we move along. And in the United States, with NASA and the private sector, 10, 12, 14 years ago, we began an experiment many of us wanted very much, where NASA made the decision, I believe it was Robin's office, to start the cargo contract, where cargo would go commercially, would go to the International Space Station, instead of what we did previously, which is where cargo and crew, the astronauts, went to and from space via the space shuttle, a government-owned and operated vehicle. And so first we started in the United States with the cargo, and then we went to crew, and that was an amazing evolution that NASA was now trusting the private sector to carry into space or transport into space their astronauts. And so those two legs prepared the way for what we're about to embark on today, which is the destinations in low Earth orbit are about to become privately owned and operated. And it's very exciting for me. I've waited a long time to be able to participate. And now we're all moving. There's 4 teams that are moving to offer various proposals to NASA on how we can have destinations moving forward. And it's very important to point out that NASA is one customer of many. They've given Voyager about $160 million, which is a small fraction of what we need. And we announced a few weeks ago that Airbus in Europe is our partner, equity partner in a new company we formed, Starlab, and there will be more equity partners to come. And what we're trying to do, what we're doing at Voyager NanoRacks is we're looking to replicate the International Space Station partnership in a commercial manner. And so if we can show the video, and then I'll sum up my remarks. So if we can see the video. And so we also have left behind having voiceover, by the way. So it's just it's a lot more international. So Starlab has a couple of, we think, advantages, certainly different characteristics than some of the other teams. Starlab will be 8 meters in diameter, far larger than the others. Which are 4 meters as they use the ISS diameter, specifications. Also, this is incredibly important to me. We're not going to be in the ISS orbit. That orbit was chosen, the higher inclination of 51 degrees above the equator was chosen to satisfy the Russian objectives. And I was there at the time when we made that decision, and it worked well for 20, 30 years, but it's more expensive to have cargo go into the higher inclination, so we're going to choose a lower orbit. We're not sure exactly what. And we're inviting others who own and operate space stations to join with us in a cluster of commercial space stations, and that way we can share resources, we can share cargo, we can share astronaut delivery, and really begin that critical ecosystem, which is what this is all about. And finally, I'll end with saying I'm different from some of my colleagues in the space industry in that I don't really focus on the hardware. For me, it's about sustainability, and we're working to develop a string of science parks around the world that will be dedicated to in-space research and in-space manufacturing, but using technoparks or science parks as a business model for how we make sure that we sustain the station, and we finally reach that point where we make the breakthroughs in materials and pharmaceuticals that everyone from NASA, JAXA, the private sector have always dreamed about. So I'll end it there.
Very good. So one of the questions coming in on Slido, I'll start with, is maybe one of the biggest obvious ones is, and maybe each panelist can maybe respond, how many private space stations are realistically estimated to come into use in the next decade? And do we expect most of these to be launched from the US, all from the US, none from the US? What are, how many are we talking about? 1, 2, more?
Well, I can start. As many as we can get. From a NASA perspective, the more the better. We like to have diversity, and we like to have competition, and we like to have redundancy. So today we have entered into agreements with 4 commercial space station partners. Voyager, NanoRacks is one of them. Blue Origin, Axiom Station, you probably saw these in the video, and Northrop Grumman. And that's for initial development. We intend to, in 2025, put out a request for proposals for a new competition. It's not a down select among those 4. It's a new open competition. We anticipate our phase 1 partners to propose, but there could be other companies that propose for certification and then services, where NASA will buy what we need, other customers buy what they need. And those will be awarded in 2026 for initial operating space stations beginning as early as possible. We hope to have an overlap period before we retire the ISS, where we have these commercial space stations perhaps starting by 2028. And so we see a range of capabilities. What NASA has put forward is our initial set of needs and our forecast of what we intend to buy, and that's 2 crew continuously and about 200 experiments per year. But that's our initial estimate. We're working with our user community to update that, and we hope to put out formal requirements later this year.
So for Japan, or globally, we're working together with NASA and the commercial partners, not just Japanese, but also US partners, to find out what the business case would be that would sustain the times after the ISS as it is now, and how to transition in that. How many would probably depend on how successful we are in finding out that demand and also being able to support that. We have had a call out for proposals to study a next possible module, a Japanese one, that could be up there to whichever space station is up there at a point of time. This is all still concept study, and we're working with a Japanese company to find out what options we have for that. So that's one of the, hardware-wise options that we're considering. And otherwise, as you saw in the video, we're very excited to work with companies to come up with, non-space or space ideas to have activities in the low Earth orbit.
I think if 10 years ago you had asked the panel, NASA's ending the space shuttle program, how many private launch vehicle companies would there be in the decade? We might have said 4, 6, tried to stretch our imagination. And yet no one in this room can even name the number of how many launch vehicle companies exist today in the world. It's been extraordinary, the change in policy and technology. Launch vehicles and space stations are not the same. Space stations are far more complex, but I think the same is going to happen. I think there'll be about 8 to 10 stations in the next 10 years. Maybe 2 from the United States, supported by NASA. You have India, you have China. I think there will be a space hotel. I think there will be a fuel depot. I think there will be a warehouse. And I think we'll cluster together, except for what's ever in the ISS orbit. And I think there'll be an ecosystem, and supported by this revolution in transportation as well. So it's a really wonderful new era we're beginning now.
So that creates this image of, when we think of space station, we think of a place that does research, and the astronauts sort of live there. And what you're describing is more of a differentiation. Yes, there'll be a research facility, but maybe dedicated to different kinds of research. And maybe there are support facilities and logistics facilities. So when we say space stations, it's more than just a place. It is really more of a network.
Right, that's what markets do. That's what commercial markets do. So at Starlab, we're not focused on space tourism. We can support it. Our partner, in addition to Airbus, is Hilton, that's doing the crew quarters, and they're going to look wonderful. But we're focused on research. We're very passionate that let's get those breakthroughs in research and manufacturing we've always dreamed about. But I think there will be tourism platforms. So you're right. I believe that the markets will have distinctions, carve out what these platforms do and focus on.
Well, then let me ask, Robin, you're deep in the middle of current station operations and research and so forth, utilization that's going on now, probably at a record level. How ready is the science community, whether in the US or worldwide, for this transition? It seems like they've gotten to the point where they now know how to use the ISS, and now we're going to kind of switch on them. We're going to say, okay, now we want you to look at these other facilities. Are they ready for this? Is there preparation? Do you see gaps that they need to do? NASA needs to do more with them to prepare? How ready are the customers?
Yeah, we're getting ready. We're really starting to peel the onion of what all this means. As you mentioned, the International Space Station capability grew over time, and now it's an incredibly capable platform. We have a lot of facilities on board. It's not just the modules, it's what's inside. It's all of those research facilities that are needed. And so one of the things that we have to plan for is, yes, the new platforms, but also what are all the facilities that we're going to need inside to enable this research? Are we going to be able to salvage pieces from the International Space Station and somehow move them over or rebuild them or maybe refurbish a ground spare? I can say from a NASA perspective, we've got some really high value facilities on board, and we don't necessarily have the budget to rebuild all of them. So we've put out our initial needs and what kinds of capabilities that we'd like to have. We're getting feedback from the platform providers as to what capabilities they'd like to provide, what capabilities that we may have to bring ourselves, and then we're working with our international partners to do the same thing and try to figure out how do we bridge this transition so that we do have all of the capabilities that we need and it is smooth. You know, yes, I think there is going to be some reset in the beginning where maybe we don't have everything that we like to have in the beginning, but then it'll build up hopefully very quickly and we'll have even more.
Well, Masami, I was going to ask, as mentioned earlier, we're probably not going to see a lot of these facilities at 51.6 degree inclination, that there'll be probably other inclinations. Maybe there will be one at 51.6, maybe salvaging things that came off of the ISS or repurposed. When you think about JAXA's research priorities on the ISS, do you have a view yet on where you want some of these private facilities to be? Or is that too early?
Probably too early. We are still studying options for all of that, but wherever it goes, I agree to what Robin said. We'll try to support our ongoing research, science, and technology demonstration that's going on. We want to also contribute with our HTV, enhanced HTVX. That's a major part. So but for the orbit, we're still weighing options.
Jeff, do you have thoughts?
Yeah, we at Voyager, we've already begun that transition for the research community. We've partnered with Ohio State University to set up the Science Park dedicated to in-space research and manufacturing. And we held our first workshop, and we got about 60 universities. And one of the things that, they came in really cautious and really nervous. This is all going to be new, but we're already working with the leading researchers on the design, on how we're going to have the equipment. This is a chance to take the lessons that we've learned from the, decades of operating ISS and do a restart. And also, let me say that from my perspective, we want new hardware. The hardware on the ISS is now a lot of it's several decades old. You want the industrial base to produce and use new research hardware, research equipment that's manufactured in 2025. And so we're getting the research community's feedback now, and they're pretty excited in the lessons that we're applying and the ability to have state-of-the-art hardware on board a new station.
So not a lot of large pent-up demand to salvage things off of the station.
I am just different. I think that there's very little value in trying to reuse research. I mean, if a lab closes in Paris, you don't hear that they're taking 20-year-old research equipment and reusing it for state-of-the-art laboratories. The industry, I mean, obviously the evolution of research equipment is amazing what can be done today. Even then, when I started NanoRacks, what can be done today in the human robotic interface and robotics and artificial intelligence and the software, the algorithms. We want Starlab to have the latest. And so that's important to us, and I believe will be our customer base.
So it's the researchers and the research they do, not the equipment they do it on, that matters more.
Correct, but they're coming from leading laboratories. And always at NanoRacks too, we've tried to make sure that the research being done on the International Space Station is done on the same equipment that you have on the ground. So if there's a difference in the research results, it's not because of the hardware, it's because of gravity.
Got it. Robin, I wanted to ask, you're again at the center of looking at what this private sector is offering, and different ones are coming to you, and NASA feels it's chosen some of the best partners it could have for competition on the private sector side. So when you look at that, without, maybe doing impolitic comparisons, what are some of the strengths and weaknesses that you see that the private sector folks are bringing to you? So you're coming from all your experience on ISS, and then you're seeing these private sector ideas coming in. When you look at that, what is it that makes you go, gee, they better think about this? Or what makes you go, that's really neat, I wish we could do that?
Yeah, I'm excited about some of the new capabilities that Jeff was just talking about, because it's true, some of the equipment on station has been around a while, and we've learned a lot, and if we were to rebuild it again, we would have some more automation, for example, additional capabilities, and so that's exciting to see. I think what I like the focus on research. That's really important as the government. That's what we're planning to do with these commercial space stations. I like to see the diversity in markets that are being pursued. I think combining a research facility with tourism, well, that's interesting. That could be a little bit challenging, but that's interesting to see. And I really like the wide range of capabilities that are starting to pop up. We have the commercial destinations that are going to be permanently crewed, and that's ultimately what we're trying to enable for our needs. But also we're seeing really innovative ideas in free-flying, single payload kind of capabilities, or sortie-style capabilities that some of the researchers are very excited about as well, because not every payload needs a permanent stay, long duration in orbit. And so these other additional capabilities, part of the ecosystem, is pretty exciting. I'll also just put a plug in to this conversation about standards. We are trying to work with, because we hope to have a number of platforms, and users are worried about where my equipment will go. Will it be able to be interchangeable on these different platforms? We don't necessarily, as a government, want to dictate, oh, you must have a standard payload rack like the station. But there are some kind of minimum, I'll call them box level payload standards that I think that would be smart and we're starting to think about that and talk about that with the commercial partners.
Masami?
Yeah, so yes, we talked a lot about research and science on the space station, because that's what we're doing now, and we want that to continue even after. That's our demand. So I'm in Washington, D.C. now for 5 years, have a small office there, and there we liaise with NASA, with the White House National Space Council, with the Department of Commerce, and all the industry and academia. It's a lot. And in doing so, and Japanese and the US and sometimes other countries also for some reason come to us, and we do hear a lot. And from that, what strikes me as being very new and exciting is the diversity of the ideas that all of these different, even within commercial destinations, so there are a few, but they have vastly diverse ideas. And maybe at some point it will converge, and we have to maybe consolidate, but the diversity at the moment is wonderful. And we have many different ideas because it's not governmental. And for that, new demands and new ideas such as tourism, but not just that, and also ways to work with international partners is different in each proposal as their technical way to deal with the existing ISS, how they want to work with the ISS and work to go further in the future. They all have different ideas. And also, Am I talking too much? It's okay. Also, also when we have Japanese companies come into that, and of course, most of them, there are some traditional, of course, the manufacturers, but a lot of the business partners are very new to space. So they come in with all these new kinds of business ideas, and also we have what we traditionally call trade companies come into this, and the trading companies have changed their mode of work from just being go-betweens between Japan and the other countries to being more of a catalyst for new ventures and investment and seeking equity. And so I see all this very dynamic and different from, of course, the time we started the space station. And the options we have are numerous. And finding out which is the best one is the challenge we have for the next few years.
Very good. So with the a topic of conversation in many parts of this conference, sort of sustainability of space activities, and particularly talking about mega constellations and low Earth orbit and so forth. And so a lot of attention has been paid to avoiding collisions between mega constellations, dealing with space debris and all that sort of thing. What consideration do you give to or have to give toward private space stations and worrying about sustainability, worrying what the orbital debris environment looks like, measures that may be taken? So we know the space station has had to maneuver to avoid debris. Is this going to be just a routine part of what private stations have to deal with? Or are there areas where improvements could be made such that it's less of a burden on the private stations? How do you think about that risk? Maybe start with Jeff.
Okay, thanks. We take it very seriously. And we've reached out to different organizations to begin a discussion of, if we imagine a cluster of space stations in a single inclination and orbit, can we declare that, we won't purposefully blow up any satellites in that orbit and inclination? Can we get an agreement among nations that maybe, we know for political reasons you won't get an agreement in general, but maybe we can get an agreement that at 40 degrees and such, you won't purposefully cause an increase in orbital debris. That might be doable, but we do think it's just something that one has to endure. I mean, that's just the reality.
Are you going to go hire people to clean up your orbits for you?
Yes. I mean, that's why this is a great new market niche, isn't it? I mean, so, the strange thing about commercial markets is one part of it may be causing a problem and the other part comes in to solve it. And so we see that with the orbital debris companies emerging. And let me say something, if I may. When I've been doing commercial space for a long time, and when we started out, there was an assumption that this was an American phenomenon. Our markets allow for this, our markets are more open, but there was an assumption at the start of commercial, what we now call commercial space, that this was limited to the United States. And I'm very proud that, the way the evolution and the relationship has developed between NASA and the private sector. I'm really glad to see that. But at the same time, I am so happy to see the activities in Japan. I mean, who would have thought 20 years ago that Japan would emerge as just this incredible ecosystem of smaller companies working on a whole range of activities. I'm jealous of they're still investing. The capital is flowing in Japan still. And in Switzerland, they have orbital debris companies, in the UK. And so I'm getting to the answer to your question. So one of the amazing things is that commercial, the non-government services, hardware, solving our problems in the environment of space, it's now an internationally commercial marketplace. So that's really one.
Very good. Robin, any thoughts on ISS collision risk?
Yeah, it's a growing problem, as we know. ISS is the debris environment has about doubled that we have to deal with, and we have to do more and more maneuvers, debris avoidance maneuvers. So it is a growing problem. I am encouraged to see a lot of commercial companies being innovative and trying to address it. And so I have hope that future commercial space stations may not have to do what the ISS is having to do today.
So in thinking about the point about growing commercial industry, multiple stations in orbit, thus giving researchers potentially more opportunities to different places they can go. So let me say, maybe ask an obvious question, which is China. China has a space station. They've said it's open to international participation. And where, if you're a researcher outside of China or the US, and you're looking to put a payload up, a package up, want to go do your science, how do you find the information necessary as to how to integrate on board? And are there areas where, at a technical level, there can or should be interchanges, maybe using the IAC to put a plug in, for standardization of research? You talk about scientific equipment, on the ground needing to match what's up in space. Great, good, actually, serious point. Are there ways that can be led to standardization of research such that researchers can have multiple opportunities to fly on different facilities when they go forward? And what's most important? Is it power? Is it size and weight? Is it comm channels? Is it who builds it? Where is standardization going to come from that will be of interest to the researchers who are looking at multiple stations they may use?
I'll take a stab at this delightful subject. Okay.
Go ahead.
Yeah.
That was a loaded question.
Yeah, first, it's a loaded question because, Professor, you jump to the assumption that a researcher could move from a Chinese platform to, let's say, an American platform. You jump to that assumption. And one of the unfortunate things about our industry is how much governmental influence, the politics, regulatory regimes, some justified, some I feel not justified. But so it's very hard to anticipate a researcher. Now, it can be done for certain countries here at the IAC, more difficult for the United States today. I will say that I was very pleased that several years ago at NanoRacks, I was able to coordinate and do I think the only commercial Chinese payload that has gone to the International Space Station. It was a Beijing University doing a synthetic DNA project, and we got to understand the Chinese payload integrate. They had flown on a satellite. They have satellites in China that you can recover the payload. And they had done some of the research on the synthetic DNA on one of those recoverable satellites, and they wanted to use the ISS, they didn't have a space station at that time, to see if they could replicate the results of the influence of the environment of space on DNA. And we learned at NanoRacks their payload integration, because they just handed over the same papers, and they were in Chinese and Mandarin, but we learned. And that's the value of cooperation. We learned how they were doing their payload processing. And so I'll say one other thing, it's not quite what you're asking, but I am astounded, I am shocked by the quality of the research hardware on the Chinese station. Some of the hardware on that station is far ahead of anything on the ISS. They have perfect zero gravity environment boxes. They have certain nuclear clock, quantum mechanics, and in satellites. Some of the things that they are doing is really worth us looking at and seeing either whether we can replicate in the West, or one day, if the politics allows, to be able to use their platform. But to finally answer your question, as Robin was saying, it's important to everybody, to NASA, to JAXA, to the research community, the private sector, that we have commonality. And that wasn't done here. The Chinese elected to use more of the Russian standards. The United States has gone in a different direction. And so it would be very, very helpful. And it is power, of course. All of us who travel know that the power is important. It's the hardware. It's the environment, the microgravity levels. And there's a lot. We're still at the very, very beginning of research in space. And so I guess I'll conclude the loaded question, the difficult question, by saying commonality would be very nice once the politics allows a researcher, at least from the West, to go back and forth.
With whether or not you want to address China, I'll leave that to you. But issues of standardization, interoperability, lessons learned you want to take from ISS to these future private platforms?
Yes, so sustainability, Japan, is very, very keen on supporting, and we place a lot of importance on this subject. As you know, at the G7 hosted in Japan, the outcome document had one full 1.5 page about space sustainability. And that was really surprising and very, very good to see coming from that high level. So we have a high political support for that, and also JAXA supports works with the industry to support that and develop the technology for debris removal. We're also working for space situational awareness. Speaking about, you mentioned China. This is, there's no borders problem that we have a proliferation of spacecrafts in the low Earth orbit. Nobody doubts that now. And we have to tackle that. Also, going on to Moon and Mars, opening our horizon a little bit, we have the Artemis Accords being signed, and this is a similar but different subject where we have to find the rules of the road to when we go out all together, we have to find a way to do this together effectively and without hindering the sustainable use of outer space, whether it's low Earth orbit or Moon or Mars or elsewhere. So that's what we're working on very much now. When it goes to commercial, I believe when commercial activities become global as this, as the problems are, I hope we have more interoperability and standardization to be able to support a global commercial ecosystem in the low Earth orbit, probably first there and beyond.
Yeah, I would just add, there's a really critical part of the ecosystem, and those, we call them implementation partners on the International Space Station today, but they're the companies who've gotten very, very good at holding a new user's hand, figuring out what they want to do, what is their research about, figuring out what hardware payload box it needs to fly in to conduct that research, and then integrating that science into the ultimate payload that will fly on the International Space Station. And that is going to continue to be critical going forward. And I really think those partners, if they are able to work interchangeably with any commercial space station, then they can provide that important bridge so that a user can come through and reach an agreement with that implementation partner and fly to whatever space station is best suited for their research. And so I think that's a really critical part of this ecosystem that we sometimes forget to discuss. We focus on the platforms, but I think those implementation partners are key to helping this ecosystem as well.
So if this is probably sort of late in the game now, given that ISS planning is only through 2030. But one of the questions coming up on Slido was, what's the procedure for a different country to integrate a new module onto the ISS. And maybe we could extend that question to maybe thinking about Gateway in orbit around the moon. If we have new countries come up that want to participate, maybe we're not involved right now. Hypothetically, what would be the process for starting that discussion?
Well, we're kind of out of ports on the International Space Station to add something as big as a new module. That's an exciting idea. However, we continue to increase the number of countries that are participating on the International Space Station. We're up to 117 now. So that's really exciting to see, and more countries are finding out how to do space research, and they want to do more. They're flying astronauts. We're doing all we can through the International Space Station. I think going forward, there'll be more opportunities for those countries to partner with some of the commercial platforms, perhaps through Artemis in our Moon to Mars program, and contribute things potentially like infrastructure, like modules or transportation or other capabilities. Some of the science hardware I was just talking about are excellent opportunities for countries to participate by bringing things like furnaces and laboratory equipment. And so I think there's all kinds of capabilities that can be integrated into these follow-on platforms.
Speaking about how many countries joined the ISS, I was before this IAC started, I was in the UN IAF workshop that was taking place here from Friday. It was, every year there's so much increasing interest from the emerging countries to join. We have been working with UN USA to conduct a project called KiboCube, where we deploy microsatellites from the Japanese module Kibo. So it's not just research, but these technology transfer capability, capacity building on Earth, and then going on to launching and becoming a spacefaring nation for the emerging countries is really a big deal, and that's been happening a lot. And something like that, the commercial opportunities can give even more opportunities. And for modules, as I said, we are considering a module, and that's in study. So we want to think about a lot of different ways to have more participation, make space more accessible to commercial partners and international partners, and we hope to find ways to do that.
Yeah, so I think it's maybe editorial comment here that the IAC, which was created to promote international cooperation and peaceful uses and progress for humanity and so forth, that interestingly one of the biggest steps or substantive contributions to making that goal a reality has been the emergence of the private sector, and not just in the US, but internationally. The emergence of private sector operations that then produce on-ramps for developing countries really at all levels of development, now have an opportunity to get on board and participate meaningfully in a way they didn't have before. And so not only building their own capacity, but building experiences through partnerships with other countries or the development of their own industry. So I would say the promise of the IAC is in part being fulfilled by the growth of the international commercial space sector. That's my editorial comment today. Any last comments? Any of you want to add?
International has never been more important, and we kind of see it. The whole concept of international cooperation is threatened today, and I really am saddened by that. So I support the IAF and everything that they're doing to make sure we have that dialogue.
Okay. With that, I want to thank everyone for joining us today and give a round of applause to our panelists.